So thanks for everybody for tuning in. Thanks to the PyTorch team for setting up this event. It's amazing to see everyone in person. I'm Lysandre. I'm the head of open source at Hugging Face. And today I'll be presenting Diffusers, bringing cutting-edge diffusion models to the community. So this isn't my talk. I'm presenting this work on behalf of the Diffusers team at Hugging Face. Unfortunately, due to visa issues and COVID, none of them could come. But I'm super happy to present it in their stead. And as I'll say at the end of the talk, this is entirely based on work that has been done with the community that I want to highlight at the end of the talk as well. So maybe to dive in, we can just take a quick look at how diffusion models work first, and then how it was implemented in the Diffusers library to see how we get to work with these models. So to explain diffusion models, I think it can be nice to start with the following question. What happens when you refine a noise vector to become a realistic image? Because that's basically what a diffusion model does. It starts from the noise that you can see on the right, and iteratively, progressively, you remove some noise from the image to obtain something, a good quality image or a realistic image. And so this is done with two components. There is the model and there is the scheduler, or also known as a sampler. And so these two working together do the diffusion process, which is a bit different when you're training or when you're doing inference. When you're training, you're basically starting from the image on the left, so the very cute cat, and adding noise at every step until you reach a very noisy image. But we try to reverse this process during inference, where you go from the noisy image back to the original image. So this is very cool, but without any other input, you're not really aware of the kind of image that you're generating. So what you'll want to do generally is to condition the denoising process to leverage some text input, for example, so that you can use the text as a prompt to condition the denoising process and to generate a specific kind of image. And so, for example, here with DALL-E 2 and the prompt a photo of a white fur monster standing in a purple room, you get this very, very cute monster. And so how does it look like with Diffusers? So Diffusers is an entirely PyTorch-based library that tries to do two different things. The first one is to provide open and responsible access to pre-trained diffusion models. You may have heard of the Hugging Face Hub. Thank you, Stella, for showing it earlier today. But basically, it provides already pre-trained checkpoint that you can just fetch and use in your Python runtime without having to retrain them yourself. And the second thing is that we want to democratize the ecosystem of diffusion models. And to do this, we try to have a very simple, very easy to use API to make it simple to anybody that doesn't necessarily understand what's happening under the hood to still be able to use them. And so to dive a bit into the code, to generate the following image, like an astronaut in a jungle using the Diffusers library, this is the amount of code that's required. So 2 import statements and then 3 statements. As you can see, we're importing the stable diffusion XL pipeline and then fetching the stability AI checkpoint directly from the hub to load it here. You can also see that we're casting the pipeline to CUDA. That's because it's a raw NN module, like most of our components. So if you're used to using PyTorch, it should be pretty easy to use diffusers. So we have a given prompt, astronaut in a jungle, with a few specific prompt augmentation to make the image look nice, and you get the following image. However, one of the strengths of diffusers is that, sure, we're using stable diffusion XL here, but we actually support a great many different diffusion models. And so here we have a very specific pipeline, but very similarly to transformers, if you used it, we have what we call auto classes as well, which abstract and that completely abstract the type of pipeline you're using under a specific task. And so here we have the auto pipeline for text to image, and you can put whichever checkpoint you want that would do text to image, and it should work out of the box. So here we switched from Stability AI, Stable Diffusion XL, to version from Warp AI, which is a super cool model that allows you to generate much larger images by using compression, and you get this very realistic cat, maybe too realistic cat, with the following prompt: anthropomorphic cat dressed as a firefighter. And so doing text to image is super cool, but something that you can also do with diffusers is to assemble different images together in order to create videos like Darth Vader surfing on a wave. And so text to video is one of the tasks that we can do, same as text to image, but there's also text to audio and many other tasks that I invite you to take a look at if you're interested in the different modalities. And so taking a look at the code here too, it's actually the exact same code with maybe two different changes. First of all, we specify the number of frames that we want in order to generate the video. And then you can see we have export to video utility as well that makes it extremely simple to export and serialize directly to your disk. However, it's not necessarily a limitation, but with the two things that we have seen so far, text to image and text to video, you have to have very specific prompts in order to get exactly what you want. And so prompt engineering is an art in itself, but it doesn't allow you to do everything that you want. So usually you want to control and to influence the denoising process a bit more. And for this, I'm going to introduce the ControlNet model. And so here, for example, we're loading a ControlNet model, and if you can see, it's called SD ControlNet OpenPose by Eliasville, a super impressive community member. And this ControlNet model is trained specifically on OpenPose. If you are familiar with computer vision and this dataset in particular, it's a dataset of different pauses, and you'll see how it works in practice right afterwards. But just loading it afterwards a stable diffusion ControlNet pipeline with stable diffusion and passing it the given ControlNet with a different prompt here, Darth Vader dancing in a desert, handing it a pause like open pause, you get the following Darth Vader, which isn't super dancing right now, but he's trying his best. And so once you add video inside with the following GIF of Darth Vader dancing, you get a super cool output without changing anything from your code. And so, as I was saying, Diffusers is super useful because it assembles many different diffusion models. So we have seen stable diffusion version 1.5 right now with Darth Vader, but there's also stable diffusion XL like at the beginning, audio LDM for text to audio, SHAP-E for 3D point generation. And something that diffusion models have an issue with generally, I guess there's two main issues that diffusion models have a bit of a problem with. There is the number of fingers on the hands. Usually they get like 7 or 4 fingers, which is super weird, or writing text, which is also super hard. And Deepfloyd is trained specifically on generating text and manages to do so quite well. So there are quite a few others, like Zeroscope that we have also seen a bit earlier. Alongside this, there are numerous schedulers that you can use within the Diffusers library. The schedulers, as I was introducing before, are one of the two main components of a diffusion pipeline, and switching from one or the other can allow you to get a very quick diffusion process, or on the other hand, something of a bit more quality. And what we try to do here is to make the schedulers as compatible with other models so that you can mix and match and create your own stable diffusion pipelines. I've shown only inference here because it's a lightning talk, but you can of course train your models also, with diffusers. And here are a few different training pipelines that you can use, but it's not limited to this. And if you're interested in training your own diffusion models, I invite you to take a look at our documentation. Last year, PyTorch introduced Torch 2.0 with torch.compile and more recently SDPA. When leveraging it with diffusers, you can get some massive improvements in terms of performance with very limited code changes, as we can see here. This is irrelevant if you have PyTorch 2.0 installed by default, because SDPA is going to be used by default. But to compile the model, it's as simple as torch.compile, as you may have seen in other talks. And so using this, you get those massive speedups, especially on lower batch sizes, but even going to like bigger batch sizes, you have some pretty significant speedups. And as I was saying before, at the very beginning, Diffusers wouldn't be what it is today without the community. It's similarly to Transformers, it's one of the projects that has been contributed the most to by the community. And I wanted to highlight 3 specific projects in this talk, but there are many other super cool open source projects that depend on it. And I think very similarly to PyTorch, what makes a very cool open source project right now is the other open source project that depend on it or the other projects that build upon it. And so in this situation, Invoke AI has been really, really impressive, building a full web UI on top of Diffusers. We have collaborated as well with Apple to have a stable diffusion toolkit that works on CoreML on iPhones directly. And the incredible visual ChatGPT work by Microsoft has been super, super impressive as well. So thank you all for coming to the Lightning Talk. It was great talking to you all.